All right, it's Belgium kit time. Everybody loves Belgium kit time. Developed in Europe, made in China. So it's kind of Chinese kit, but made in Belgium, or designed in Belgium. And a little bit of Dutch on it. All right, so this is a 2-channel IR remote. So I've bought a couple of these Velleman kits cheap off of eBay because nobody wants them. So I got these for $1. Now, the price on this originally was $19.90. So remember that, $19.90 for a 2-channel IR remote. It doesn't even have the receiver. It's just the light flasher. 20 bucks. So, yeah, let's get it out onto a tray. Nice. All right. Let's see if we can't get the staples out. All right, does it have schematics? It does, yay, it has schematics. A bunch of papers too. Let's see here, let's see what we get. We get a piece of paper to all residents of the European Union. Nice. Nothing about America though. What about America? Let's see, what is this? Instructions. Hold both buttons simultaneously to change channels. After 5 seconds, the red LED will flash at 1-second intervals. Okay, so we have instructions. We better keep a hold of those so we know how to make it go. Here's the instruction. Oh, look at this guy. Look, he's using his remote. He's very happy. And here's a lady trying to get her rocket launched, and it's not doesn't look like it's working. It looks like a little fizzly thing here. Maybe it's not going, but I guess you can use your 2-channel remote to control your rocket ship. So keep that in mind. Here is the schematic. Is it on screen? There we go. So interesting. So they have one visible LED and 2 infrared LEDs. So you're making the infrared LEDs go, and the visible LED will light up with the base current. And then there's switches, and then there's a PIC 12F629. So it's microprocessor controlled. How exciting is that? All right, let's build it. Comes with a case. Interesting bag. The bag doesn't feel like a modern bag. It feels, I don't know, it doesn't feel like bags I'm used to. Come on. Stuck on the bag. Like I said, these bags are kind of weird. I think the resistor is poked through the bag and it won't come out. There we go. All right, let's take a look at the PC board. Whoa! This is super, super thin and a little scary. Single-sided. I guess it's okay. I guess the quality is okay, but it's very, very thin. I think this is one of the thinnest PC boards I've ever come across. Here's our microprocessor. Oh, keychain. LEDs, some parts and stuff. Here's the case. We won't open that right away. Battery. I'm not sure what kind of battery it uses. Yeah, let's whoa. Let's get it built. All right, before we build it, let's say goodbye to our friend, the soldering spool. I've used it all up. This was a Kester 44 6040 lead solder QQS 571, and I have used it up. So we're now going to this one, which is a Kester 44 6040. So I just love this stuff. I'll insert a picture here as a close-up. Yeah, so look at that beauty. It's a beauty. Very nice. And it's 1 pound. Feels good in the hand. All right, let's get this thing built. All right, we will start with these resistors. They're little tiny resistors. I think these are 1/8 watt. These are teeny tiny ones. But you can read the color codes on them. So these are 100Ks. R7, R8, and R9. 7, 8, and 9. Okay. 7, 8, 9. Here's 9. Stick him in. Oh, I have to bend the leads a little tighter with these tiny things. Okay. I thought maybe they were going into regular size spacing, but no, they have it all squished in. Let's make it small because it is a handheld remote. All right. Bend these better. 7, 8, 9. Here's an 8. And a 7. So I had pizza with some friends of mine. We try to get together once a month. And there's some people there who are retired and some people there who are still working. So sad. But the reason I brought it up was there was Christmas music playing in the background. Oh my God. Oh my God. When Christmas music's going to start playing in July next year, I think. I don't know. It's terrible. Terrible, terrible. And it'll be a couple weeks from now when this video comes out, so remember that. It was actually a couple weeks ago that I was complaining. All right. Oh man, that one's all bent. Oh well. So it's ugly. Deal with it. All right, got the magnifying glass. Let's read some color codes. This looks like a 47K. 47K. That would go. It's a 47 ohm. Oh, 47 black. Oh yeah, it's a 47 ohm. All right, R3. All right. Next one is a 47 470. That would be R2. R2. All right. And a 470K, 470 ohm again, which is maybe a bonus, maybe that. Oh no, R1. They're not going to give me extras. No extras. Well, my channel's up pretty good. It's up to 13,000 subscribers. And my channel's had 2 million views. So Google identified or sent me an email saying, your channel has had 2 million views. Congratulations. And some of the other vendors, of course, want my patronage, and they want me to hawk their goods. I'll take some people up on that. Banggood supplies me with stuff to review, and that's always been a good thing for me and the channel. And there's some other companies who will probably be submitting some things for review. I've done it. Ouch! I've done it for other products in the past. I always let you guys know, though, when people give me stuff for free. But I like free stuff. I broke a cardinal rule the other day. I actually did some consulting. Kind of swore off consulting, so I was not going to do that anymore. But I got recommended. I got recommended from somebody who I have ultimate respect for. So I told him I'd give him a couple hours. I spent a couple hours on the telephone telling them what they were doing was not going to get them to where they wanted to go. Tried to get them on a better path. This one is 333 k ohms, R4. They were building cameras for drones. What did I say? I just said R4, didn't I? Yeah, R4. Yeah, cameras for drones. And they were having problems with their auto white balance algorithm. Your camera needs to take pictures, I always want to say regardless of the illuminant being used. So there's something inside digital cameras called auto white balance. And it's a closely guarded secret at most companies how they do that. It's not an easy, oh no, I screwed that one up again. I chopped it too close and it pulled the pad off, I think. Done that before. So these cheap PC boards, you cannot attach them. You cannot clip them close. You must leave a big blob. So don't try to get down right on the PC board. I'm going to test that with a continuity checker. Anyway, they're trying to fly drones around for the military, and I think it's for the military or some kind of commercial application. They want to make sure that their drone takes good pictures regardless of the sun condition. I think that's okay. Let's check it from this side though. Which is the one that counts? Yeah, we're okay now. Saved it. So I think I'll take the money, buy myself a laptop. I kind of need a laptop for the garage. I've got one in the garage, but people know that I don't like PC-based instruments and stuff, and I try to avoid using laptops. Sometimes you can't get around it. My laptop's just a little long in the tooth, so. All right, do not snip them close. Okay, good. All right, one more resistor, 333.33. It's another R6 over there. All right. Now, it has a bunch of diodes, but one odd one. It has 2 regular diodes and 1 Zener. It's a 12-volt battery. Oh my God. 12-volt battery? You're kidding me. Oh man, I hate this kit already. Yeah, 12-volt where do you get a 12-volt battery that tiny? Oh well, it's got a 5-volt Zener, so we have a regulation on board. ZD1. ZD1's over here. Oh, that's a... Oh well, I'll just hook up bench supply. My daughter got lucky yesterday. She was at a store and they had things hidden around the store. And if you found an envelope, like the golden ticket, you got 20 bucks. So she found one. She got 20 bucks. Of course, she had to buy something. So, but she got free stuff, just like her dad, getting free stuff. One of the guys that I have pizza with, his daughter's on Instagram or TikTok. I think she's on TikTok, and she's got like 160,000 followers or something, and she gets free stuff. Companies like send her free dresses so she can wear these dresses and dance in front of the camera. That's where you really make good money on YouTube, is being somebody that people want to watch. People like my hands, of course, but people actually like to think they're friends with people who probably don't want to be their friends, but they want to enjoy other people and make them into little mini celebrities, and people just like to be social. You'll have to pardon my non-social behaviors. All right, let's put some switches on. I'm not looking to make friends, I'm just here to teach. Hopefully I'm teaching and not just being entertainment. It'd be sad if I was just entertainment. I hope that I'm teaching you something. Although maybe building kits isn't the most beneficial way to be teaching. But I have had people comment that they built their first kit because they watched me build a kit. So that's pretty cool. So I guess it's okay, right? So I encourage somebody to go out into the garage and pick up a soldering iron for the very first time. And that's worth it right there. If I got somebody to do that, that's just awesome. My goal is to get people to spend long enough to watch my videos and then not spend any more time and go out in the garage and try things out, design things, fix things, build things, hack things, just do things. All right, T1, there's only one transistor. So I guess it only goes in one spot. I've got a cool build coming up. I'm not quite sure how to video it yet. It'll be quite a lengthy build. I'm not really too interested in actually filming the whole thing either. But I know a lot of people will be interested in it, so I will certainly... My soldering iron just turned off because I have it on a 30-minute timer. Okay. And we've got LD1, LD2, and LD3. I think those are light emitting diodes. And I'm assuming that that's the positive. So it goes like that. These diodes are going to be somewhere around 680 to 820 nanometers. That would be my guess. Those are typical IR frequencies. Never really. I built a lot of LEDs in my career, but IR LEDs was not the type of LEDs I was associated with. I was always associated with ones with the visible light. So I'm not quite sure what elements they make IR LEDs out of. Gallium arsenide, maybe? I don't know. Not sure. All right. And we've got a red one. I was watching a video online and somebody was using an LED as biasing for a amplifier. I've showed a lot of those online where I use two LEDs back to back to bias the push-pull section of a amplifier. And two diodes back to back gives you a voltage of about 1.7 and 1.2 maybe. And you can just use one LED. So that's kind of fun. You could have something glowing in your circuit doing the same job. I've used LEDs before in circuits as a voltage reference. Sometimes I just need to create a voltage a little bit higher than the ground and use an LED for that. All right, it is socketed. Do we want to socket it? Yeah, I guess so. Comes in the kit. Comes in the kit. Maybe we... What's the pin out of this? Pin 8, pin 1. I was kind of wondering if a Atmel 85, 84, 83, 85, 85 I think, right? Little 8-pin microprocessor. I wonder if it has the same pin out. Or if I could hack it. I don't do any PIC programming. But I've used 8-bit, I mean the 8-pin AT8085. Yeah, those are cute. I've used those before. It's got a little jumper area here. That probably sets maybe a code for the remote. All right, looks like there's a diode here. Did we get a diode? We did get a diode. I mean a diode capacitor. 104. Did you immediately say 0.1? Should have. Okie dokie. There we go. And it won't work without the micro, as tiny as it may be. There we go. All right. Plus plus, minus minus, plus minus. Let's just put some wires on it. so we can make it go. We'll use these leads that we've just made a mess on our table. Use those for our making contact. $12 volts. What kind of battery is that? What kind of battery is 12 volts? It doesn't even say. Wow. I don't care. Because I'm not going to go buy one. 12 volt battery. All right. So, 12 volts. Well, I got 12 volts. I got 12 volts right. 15. These are 15 volts. 12 volts. Okay, I'll make 12 volts. Turn my power supply down. 12 volts. Let's bring it over. Minus, plus. Push the button. Nothing happens. Oh, great. The LED is not lighting up. That's unfortunate. Maybe you got to push them both down? Like it said? No. Nothing. Nothing at all. Interesting. Did I install diodes backwards? Let's check some voltages. That's what a voltmeter is for. Okay. Do we have 12 volts? Yes. Do we have 5 volts? Let's see. 5 volts will appear only when we push the button. And it will appear on pin 1 when we push the button. And we do. We get 5.2 volts when we push either button. So that's a good thing. So those diodes are in the right direction. And then we have something should come out on pin 5. So let's hook up an oscilloscope. That's what we have oscilloscopes for. All right, pin 5. Ooh, yes, pin 5 is doing something. Nice. Okay, one of the things I hate about this Rigel is whenever you turn it on, you have to tell it you have a ×10 probe. Be nice if it could remember that, but it doesn't. And I can't change here to 2 volts. When I push the button, yeah, I'm getting data. Yeah, there we go, little pulses of data. Nice. Okay, let's change this one click. And let's do a single event. There we go. And we can zoom in on our single event. Zoom, zoom, zoom. And it looks just like pulse, pulse, pulse. I don't see a code on it. And that pin 5 goes through the LED. The LED's just too dim to see? No, I just don't see anything in the LED. Maybe I put the LED in backwards. That'd be embarrassing. I'm being an LED person. Yeah, let me check that out. All right, rookie mistake. I did put the LED in backwards, so you can see that now the LED is flashing, which means the infrared LEDs are flashing. So we can look to see what kind of codes we're getting out of this thing. If we get any codes. Let's put scope probe on. I think we can hang it right on this lead here. Yeah, let's turn my scope back on. Yeah, I'm getting some pulses there. They look kind of ugly, but I like to pin 5 better. I like to pin 5 better. Can I get my probe on pin 5 without shorting anything? I think that will do it. Yes. All right. All right, so I am probing pin 5, which is the output on our schematic here. Can you see that? Pin 5 is the output. It turns on and off that transistor. And we are getting pulses. And I don't see much difference in these pulses. Where's our... Got those types of pulses and those types of pulses. So I'm pushing button 1 and now I'm pushing button 2 and they're doing the exact same thing. Interesting. And now I'm going to push both buttons down and oops, disappeared. Now what did the instructions say? Remember? Read the instructions. Hold both buttons down simultaneously while to change channels. After 5 seconds, the red LED will flash at 1 second intervals. With every flash, the next channel is selected. All right, I'm watching the LED. And it is flashing now. Oh, what changed? That's one, that's the other one. Did anything change? God, I don't see anything. Is that number of pulses? This doesn't make any sense to me. Very strange. Very strange. Well, I don't quite understand what the difference is channel 1 and channel 2 is. That makes no sense. We should put a solder blob on one of those things on the bottom. They don't really say what those are for. They do not. GP, I'm assuming they're for certain codes or something. I thought we could decode it. I thought we'd get a cool pattern and try to figure out what kind of code it is, but that's no code at all. No code. Let me flip it upside down. I will put a solder bridge on one of those pins, those little solder blob things. We're shorting 2 things out, and that will connect it to ground. And then we will see if we get a different code out. Nope. Nothing. Well, that's boring. It's just flashing. You might as well have a clap on, clap off. All right, well, for this thing not to go to waste, let's take a look at the schematic in detail and see what the designer did. See if we can learn something from The clever Belgian. Okay, so here is the circuit. I think the one of the clever things is pushing the button also is telling it to do something, but at the same time turning the power on. Okay, so it's connected here to the 12 volts with 470 ohms, and that comes in this switch or this switch, and they're wire ORed or they're diode ORed together, right? So you can either get power this direction or get power this direction. And that goes right in here to VDD, and that goes over here to the Zener diode. So this voltage here would be 5 volts, and it's regulated so it doesn't blow things up with this resistor up here. I don't know if I would have put the resistor up here, down here, but anyway, it's fine the way it is. And then it's also bypassed with a 100 nano, that's our 0.1, 100 nanofarad capacitor here. And then this is the jumper area. This is where I was putting those solder blobs. This one has a 100K resistor pulling it up, but these are open here, so I don't know if it only has, maybe only one of these works, or I don't know. Anyway, that's what all that part of the circuit does. Now, what I said was, when you push a button, it also tells it what to do. And so you push the button, it powers it up, and it also comes over here, and that 12 volts gets divided down with a 35K, a 33K, and a 100K, so that it's 5 volt compliant. So that's a clever thing. They have a 12 volt signal, but they need it 5 volt compliant, and they do this by dividing it down by 2/3. That still seems a bit high, doesn't it? Anyway, let's see. When you press it, 5 volts. Yeah, I think what it is when you press it, it's going to be 12 volts initially, but then it hits this Zener, and then you have 5 volts here, and that 12 volts will probably be 5 volts plus a diode drop above. So these probably don't get to 12 volts, they get to 5 volts plus a diode drop. Okay, so maybe 6 volts here. And then you divide them down a bit to make them 5 volt compliant. So that's a bit dodgy, but okay, fine. And then all this thing does is output a clock, or output some kind of pulse stream. That comes out on this pin 5 here. It goes through a 470 ohm resistor and an LED into the base of the transistor. Now, I think that's a big fail in this circuit, that this LED just doesn't turn on. It's very, very weak, and it just needs more drive current. So I think having a separate path. So what I would do is I would branch this off and put the diode to ground here, okay, and have this straight through. So you have one path that drives the transistor, and then one path that actually turns on the LED, and that way you can use a nice healthy resistor here to make that LED nice and bright. Or you could put the visible LED over here, right? You could have the visible LED over here. So that might be even a better way to do it, because then you have a nice healthy pull down with this transistor here, and you turn on these LEDs and the visible LED at the same time. Or you could put the visible LED in series with everybody, okay? That might be a clever way to do it. Have diode, one visible and two in infrared. So I think I like that one the best. I think I would do it that way. So anyway, so teaching experience, I got my $1 worth out of the circuit. We can take a look at what somebody else did and then maybe critique it and make it better for our use, or if we were going to design this, try to think of what we would do different.